Hi, Mr. Zapone here, and today we're going to look at reporting measurement values and how we're supposed to do it. And suppose you had a rectangular solid, and I asked you to tell me the volume of that rectangular solid. And in order to do so, I gave you a ruler, and you measured the length, width, and height, and you came up with the following dimensions. The rectangular solid was 2.74 centimeters by 2.23 by 2.68. And to get the volume of a rectangular solid, you simply multiply length times width times height. So that's straightforward. And when you put these in your calculator, you get this number right here. Now there's a problem with this number. Each of your measurements have 2 decimal points, or 3 total significant figures. Basically what you're telling me is that you measured this to within the 100th of a centimeter. Your instrumentation, your ruler was accurate, or allowed you at least to measure the dimensions of this cube to within a 100th of a centimeter. But your answer is given in 1,000th of a centimeter. And there's a problem with this. A measurement or result cannot be more accurate than your measuring devices. So as we're going to see, calculators tend to give us errors because they assume all numbers are exact numbers. But when you're measuring something, if you only know something to 2 decimal places, you really can't report a final answer to 3 decimal places. It doesn't really work that way. So our results cannot be more accurate than our measuring devices. In fact, we'd have to actually round this. We'd have to make this 16.4. That would go up to 16.4 centimeters cubed. Basically, each one of these has 3 significant figures, so this one would also have to have 3 significant figures. But it just obviously on the surface, you measured accurately to the 100th place, and your answer has a result in the 1,000th place. We can't actually do that. So, and let's take a peek at reading a meter stick / ruler, and these images are from a Pearson chemistry textbook. What would you report this measurement as? The only labeling on here is that this whole thing is a meter, and we know it's between 0 and 1 meters, and this looks to me to be a little more than half, and a good estimate with this would be 0.6 meters. You can never say this is 0.61 or 0.601. The rule of thumb is when you're reporting a measurement, you can only have one uncertain digit. You can only allow to estimate one digit, and this whole scale is given in meters, so you're able to go over 1 decimal point of uncertainty, and this will become clearer as we move along. The second one, we know that this block is now between 60 to 70 centimeters, or 0.60 to 0.70 meters. That is for certain. It's absolutely within this range. But where is it exactly? Well, we are allowed to estimate one digit, one uncertain digit, and I would call that 0.61. And again, this 1 and the value is my uncertain digit. It's my estimated number. I know it's between 0.6 and 0.7. It's very close to 0.6. I'm allowed to estimate one digit. Same thing here. Our scale is getting a little more fine-tuned or involved. This right there, I know for certain that it's between 60 and 61 centimeters. 60 to 61 centimeters, or 0.60 to 0.61 meters. I know it's in between there for sure, and I'm allowed to estimate one uncertain digit, so I'm going to add to that, and I'm going to say that this is 0.607. It's not quite at the 61, it's just a little bit before it, and again, I am allowed one uncertain digit when I make a measurement. So if we wanted to read this graduated cylinder, and we have a zoomed in picture of it, we know that this is 15, so 16, 17, 18. You know for certain that it's between 17 to 18 milliliters. And it doesn't quite get to the 18, so we know for certain that it's 17 point something. But 17 point what? Well, we don't know exactly because we don't have more lines in here. But we are allowed to estimate one uncertain digit. And this looks to me to be about 0.6. You might call it 0.5 or 0.7. But you are allowed one uncertain digit. You should not go beyond one uncertain digit when you are making a measurement in science. So whatever your hash marks or your labeling or your scale is on your instrument, you're allowed to estimate one uncertain digit. That's the rule. And again here, we can report one uncertain digit. So this is in centimeters. And I know it's between 1 and 2 centimeters, and these are actually the centimeters broken into 10 spacing. So this is 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7. So I know this is between 1.6 to 1.7 centimeters. And that's for certain. So I know for certain it's 1.6 because it's not quite at the 1.7, but what am I going to estimate this as? You can estimate one uncertain digit, and I'm going to call that 1.67 centimeters because it looks closer to the 1.7 than it does to the 1.6. So again, you are allowed one uncertain digit. That's how we read devices with calibrated marks on them. And just to finish up, we'll look at these three measurements. Here we have a graduated cylinder measuring in milliliters. You know for certain it's between 5 and 6. So you know it's going to be 5 point something. We don't know exactly what it is, but you're allowed to estimate one uncertain digit. I'm going to call that 0.3. 5.3 milliliters. The same holds true for this one. This one looks like it's exactly on the 15. And we would have to report that as 15.0. It's very important that you include this other 0. And it might be hard to see why because it's exactly on the 15. But if this line actually extended all the way to, say, here. Let's say this was a little bit bigger, this object. Well, this is 15, this is 16, 17. You know it's between 16 to 17. You'd have to report one uncertain digit. You know it's not at 17, so you know it's at 16, and you would estimate one digit, 16.5. So even if it's exactly on the line at 15, you still got to let whoever you're reporting your data know that you were able to measure it with the precision of at least 1/10 of a centimeter. You have to report that value in this way. And this is the same situation as up here, except in between the centimeter 15 to 16, and this would be 15, this would be 16, they put 10 hash marks in here. So you could actually go a decimal point further. If this is exactly on the 15, you'd have to report this as 15.00. And your uncertain digit would be right here. And your uncertain digit here is this one. So you always need one uncertain digit, and your measurement has to reflect the depth or the fine details of the instrument you're using. So you have to report a measurement properly. Remember, always allowed one uncertain digit, and the results of a measurement should never be more accurate than your devices themselves. This is Mr. Sapone.